Hello and welcome to another tutorial. In this tutorial, we'll be making a snakes and ladders game inside a Visual Studio using WPF and C#. Let's run the demo. As you can see, as soon as the game loads, it loads up the board for us, and you have the location for the ladders and the snakes, and the player and the CPU has been positioned at the 0 location here. So when I click on the board, it generates a number between 1 and 6. It will move the player and the CPU forward according to the number that's generated. If you land on bottom of a ladder, you will move up to where the ladder ends, and if you land on the mouth of a snake, you will move down to where the tail part of the snake is. So if I click on the game some more, as you can see, the player and the CPU is moving. So right now the CPU has landed on the bottom of the ladder and moved up to, from 15, it moved up to 26. If I move the player some more, okay, so the CPU landed on the mouth of the snake and moved down to, from 46, it moved down to 25. Okay, so the player has landed on the bottom of this ladder and moved from 36 to 44. Okay, we jump to the ladder again. Okay. We've been eaten by a snake, so we moved from number 95 to 75. Okay, we moved up to 94. We could just go eaten from there. Right, so one of the rules for this game is that when you make it to the top, if you make it to 100, you win, and if the CPU makes it to 100, the CPU wins. However, when you're right at the top of the board here, you'll have to generate the exact number of steps that you need to complete the game. So right now the CPU is at 98. It needs to generate a number between 2 and below in order to get to number 100. So if I press again, so right now the CPU has rolled a 2 and it made it to 100, and you get a message to say the opponent wins, and we can click OK to play again. So if I click OK, the game will reset and both of the player and the CPU will be positioned back to 0 again. Okay, this will be a fun tutorial to make, and let's get started by creating a new project in Visual Studio. In this window, click on Create a New Project. Make sure you pick the WPF app.NET framework. Let's name this project. I'm going to name it Snakes and Ladders WPF Game MooICT. Click Create. This is the blank view of the project. One of the things we need to do is you can download the images that we need for this game from the link below. Let's just take a look at the images. These are the images for this game. So first we have all of these little rectangles that represent the part of the board, and each of them will be combined together to make the whole board. So we have between 1 and 100. Then you'll have the opponent's image and then the player image as well. And these are the ones that we're going to be using to move the player and the CPU on the board. Okay, so let's set up the game board. So I'm gonna the width can stay at 800, the height can be changed to 800. Change the title of the game to Snakes and Ladders MooICT, so it just shows up there. I'm just going to zoom out of this one a little bit. It's a lot easier to see the XAML code. Okay, we're going to change the grid to a canvas. Let's give the canvas a name. And canvas, set focusable to true. Let's add the mouse left button down event. Let's say on click event, and then set the background to gray. Okay, so that's been changed in there. Inside the canvas, we will need to do a few things. So for example, we'll need to set the title, the information, the player and the opponent here, and inside in the middle here, that's where the board is going to be generated. Okay, before we start, let's import the images that we need for this game. So go to the Solutions Explorer, right click on the name of the project, click on Add, click on New Folder, type in images here, and then we can right click on the images folder, click on Add, go to existing items. Okay, you can go to the downloads, and then where you extracted the images, just go to the folder, select image files. Okay, so because there's quite a lot of them, so you can select one, press Ctrl A to select all of them, and then click add. Okay, so now all the images will be added here. Okay, let's do a label first. Set the font size to this one to about 26. Font weight can be extra bold. Content is going to be snakes and ladders game more ICT. Foreground set to white, and then we can end the tag here. So as you can see, it gets added right there. I can move that manually to the middle of the scene. Select this line, press Ctrl D. So this is going to be the second label that we're going to need. Okay, so if I select that one, and then I can move it down a little bit. As you can see, it adds the top position and the left position. The left position is exactly the same as the before, and the top position has been added as well. So I'm going to change this one's size to 16, and this is going to be the information on how to play the game. So let's say click anywhere on the game to take your turn. CPU will take turn after you. Okay, so that I can manually move it here. You can also use the arrow keys to move it slightly up. You can move the snakes and ladders title slightly up as well. Because this one is smaller, we don't need to make it extra bold. Just bold is fine. Okay, so that's the top part sorted out there. So now we need to add the images for the player and the opponent and the bottom of the scene. Let's make a new image tag. Source images slash player.gif. Width set to 30. Say canvas.left to 70, and then canvas.top to 709. And the tag there. So the player gets added right here. Let's add the opponent. I'm just going to duplicate this line and change that to opponent.gif. So as you can see, it turns purple there. This one's location is going to be 497, and still in the same location from the top. Okay, so now we're going to need two labels for the player and two labels for the opponent. These will tell us what we rolled and the position that we're at. Label, let's say name is txt player. Font size to 16. Font weight, let's just say bold, so we can see it better because the text size is going to be smaller. Content going to be setting up to be 00 first. Say canvas left to 105. Canvas top to 709. 109. Okay, so that gets added right there for us. Okay, so zoom in on there so we can see better. Okay, let's just duplicate this line here. So this one's going to be txt player position. Okay, and the content is going to be player is at with the at symbol 00. That's the default of it. And what we're going to do is we'll set the top position of this one to 733. So it's a bit below from the top one. Right, so if I copy and paste these two, so with both of these lines copied, we change this one to txt opponent. Okay, change the left of this one to 532. Okay, and this one's going to be txt opponent position. Okay, and then we are also going to be changing this one's left to 532. Okay, change the text over here to opponent is at. Oh, sorry, I think I made a mistake here. I said 523 instead of 532. So now they're both symmetrical. Okay, so that would do for the UI for this game. Right, so we have the top locations, top information given when the game loads, and we also have the player and the opponent information loaded in the bottom as well. Okay, so now to go in and write up the C# script. So before we do that, we need to add the mouse click event that's attached to the canvas here. So if I right click on the on click event keyword there, click on go to definition, and then it adds it to the C# script. So right here we need to import the threading namespace. So say using system.windows.threading. Okay, so we can import the dispatcher timer inside of this project by using this. Okay, let's make a few custom functions. So in the bottom here, we need a private void setup game. We also need a private void restart game. We're going to need another function to check whether we landed on ladders or snakes. So say private int check snakes or ladders. Okay, so this function is going to return a integer variable for us. So we can also say int num, so it's what number on the board that we have landed on. So just say return num here for now. We'll add some more bits to this one. So this is going to be the longest function in this game. Then we need a private void move piece. Inside of this one, what we need to do is we need to pass in two values. So the rectangle is going to be called, let's say, player. So this is going to be the player or the CPU, whatever, whichever rectangle that we pass in through here is going to move the rectangle to the position on the board. We also need the name, so we're going to run a string. Let's call this one pause name. So it's the name of the position of the rectangles on the board. Okay, so let's go and set up the variables for this game. A rectangle, this one's going to be called landing rec. So this is where the player or the opponent lands on once the move has finished. Okay, so we're gonna need a rectangle called player. We need another rectangle called opponent. We'll need a list of rectangles. Say list. Let's make a new list called rectangles, and then this one's gonna be called moves equals new list. So we initiate an empty list here. Let's make a dispatcher timer called game timer equals new dispatcher timer here. Okay, and then we're gonna do with a couple of image brushes. So image brush is called play image. Image brush, let's call this one opponent image. Make a new int here called I. We're gonna give this a position of -1. Int j equals -1. Int I is going to be for the player movement. Int j is going to be for the opponent's movement. So by default, we want it to load up with a -1 number. Okay, let's call this one int position. This is for the player. Int current position, that's for the player as well. Int opponent position, and then int opponent current position. Let's do an int for images equals -1. Need a random class, so I say rand equals new random. We need two booleans, say player1 round and then player2 round, and we also need a int for a temp position here as well. So these are the variables that we need to make this game work. So inside the main window constructor, let's run the setup game here. So it's going to load the setup game as soon as the program loads. Inside the setup game function, we're going to be setting up the player and the opponent images. We also need to set up the grid for the game. The way the snakes and ladders grid actually work is kind of different. So let me just show you this one. In this grid, we have the board layout. We start from the bottom of the board. We will use 3 different integers to calculate the position of the boxes. We will use a left position integer, a top position integer, and an integer called a. We are placing 10 boxes in each row. To move each boxes to the right, we are adding the box width to the left position integer, as shown here. So that's the left position integer here, going plus equals to width of the box. And to move the boxes from right to left, we are reducing the left position integer by the value of the box width. The top position integer will be reduced by the height of the boxes once 10 boxes have been placed. As you can see, we go from 0 to 9 boxes here, and then when we move to number 10, the top position integer will be reduced by the height of the boxes until we place 10 more boxes on this row, and then it will do the same again. So the idea is we place 10 and then it goes up until we reach the 100 box. The a integer is going to be used to calculate how many boxes we have laid on the board so far, and then once we have laid 10, it will allow us to move up and then add 10 on the other direction. So this sort of helps us to calculate the direction of the boxes, because all the boxes are going to be named and we need to move the player and the CPU accordingly to where those boxes are. This is the most efficient way I could find to lay out the snakes and ladders board. Okay, so to get started, let's say for example here we're going to be making 2 local integers. So let's call this one left position. The default left position is 10, and then the default top position is 600. We also need another int called a. So this is going to help us calculate how many we have placed, and then whether to move towards the left or to move towards the right. Let's set up the player image first. Image source equals new bitmap image. Inside of here, let's say new URI, brackets again, quotation marks, and then say pack colon slash application colon 3 commas, okay, images, and then player.gif. So we're just going to duplicate this line and call this one opponent image, and then load up the opponent gif inside of this one. Okay, so now we need to run the for loop. So inside the for loop, we always get an int I that's equal to 0. That's fine, and this is going to be instead of length, we're going to set that to 100. So we want whatever is inside of this one to run 100 times. So inside of here, we're going to say images ++ new image brush. Okay, we're going to call this one tile images equals new image brush. Okay, so now you can say tile images there, say image source equals to, copy this line here. So instead of it being any of the opponent, we're just going to end that tag there. We say plus images, then plus.jpg. Okay, so whatever the image number is generated there, because it's going to go plus, so it's because it's starting at a -1. So each first when it runs, it's going to run at 0, then 1, 2, 3. And if you look at the images that we have, it's all JPG. So the first JPEG starts with 0, then 1, and then 2, 3, 4, 5. So it goes all the way to 100, all the way to a 99. Okay, so when we create a rectangle for the board, we will be assigning this image tile image here to each of the rectangles that we create. So let's create a rectangle here called box equals new rectangle with curly brackets and do a semicolon in the end. Just zoom in a little bit. Okay, so now we can say here is set the height. Say set the height of the tile to 60. Set the width of it to 60 as well. The fill is the image. So tile images is fine, comma. Then we do a stroke equals brushes dot black, so it has a border around it, and then stroke thickness can be equals to 1. So what this is going to do is it's going to create 100 new boxes for us, right? And what we also need to do in WPF is we need to register a name for each boxes. So we need to give it a name like box 0, box 1, box 2, the way we saw in the picture earlier. So we're going to say box.name is equals to box plus i.toString 1.toString i. And in WPF we also need to actually register the name to the app. So what you say is this dot register name, right, box dot name and then box. So this way each individual box that is created will have its own individual name as well, and with that we can use the move pieces function. That's why we have the position name there. So with that we can actually move the position of the player and the CPU accordingly, still inside the for loop. Yeah, so moves dot add box, so it's the moves rectangle list that we created earlier. Okay, so this is where we get to position the rectangle left and right depending on how many rectangles we want to position in one row. Okay, so say for example if a is equals 10, right, we're going to say top position top pos minus equals 60. So once we have reached 10 in one row, it's going to move the row up, and then a is equals to 30. Okay, next we can say if a is equals 20, then we move the top position again to minus equals 60. We move the row up again, and then we set a back to 0. The reason we're doing it in two different ways is because we're creating a layer which is moving towards the right, and then once it stops there, it's going to move towards the left. If a is greater than 20 first, let's say a minus minus, so when it reaches the end, so that's when it becomes 30 there, a minus minus, and then we can say canvas dot set left box and then to left position here. Then right under that we're going to say left position is going to be minus equals 60. So this is when the boxes are moving towards the left of the screen, so reducing 60 from the left position. And if a is say a is less than 10, then we're going to say a plus plus, so it's going to add 1 to the a integer each time the for loop runs. Then we can say canvas dot set left to box and left position again, and we say left pos plus equals 60. So this time it's adding it towards the right. Say canvas dot set left to box and left position. What I found is a lot of times it would add a box outside the width that we want, so having this line actually reduces the chance of that happening. So outside of these two, we're going to say canvas dot set top box, and then we'll have box tab position here. Okay, and right after that, say my canvas dot children dot add box. So it will finally add all the boxes that we need inside the my canvas. Okay, so just to see how it looks, let's run the game and see what happens. So as you can see, all the boxes have been placed appropriately for us. So you move from number 1 to 10, and then as soon as it goes to 10, it moves up and adds it to 20, 21, and then 31, 41, 51, 61, 71, 81, 91, and then we got the 100. Okay, I think everything looks fine. Okay, so outside the for loop, let's set up the game timer. So game timer.tick equals game timer event. Okay, and game timer.interval equal to time span from seconds is fine, and we're going to run it at 0.2 seconds. Right, After that, we need to set up the player rectangle and the opponent rectangle. So I'll say player new rectangle, set up player height to 30, comma, width to another 30, comma, let's say fill equals to player image that we set up earlier. Let's say stroke thickness, we're gonna set that to 2. Okay, the same for the opponent again. Set the height to 30, the width to 30, fill to opponent image, and then stroke thickness to 2. Okay, so that would do the player and the opponent. Now we also need to add the player and opponent to the canvas. Player, and if I just control D on the line, then I can just duplicate that and then type in opponent. So what we also need to do is, as soon as the player and the opponent are added to the board, what we want to do is we want to move them to the default location on the board, right? So that's going to be the 0 position for the player and the opponent. So we're going to say move piece right here, and then let's move the player one first to box plus 0. So that's gonna, so right now the function is empty, but what that function is going to do is that function is basically going to move the player position, so the player position to the first box. So that's located at box 0. Let's do the same for the opponent. Okay, so the setup game function is now complete. I can minimize this one. If you want to maximize, you can also press the plus here and then maximize it to see what's inside. Okay, make sure you save your project frequently, so any changes that you make, Control S all the way. So let's do the move pieces function. So this function is going to be quite simple. We're going to run a for each loop here, and what we're interested in, we're looking for rectangle, right, called rectangle, right? And then inside of what we're interested in, inside of the moves list, if rectangle dot name is equals to position name. So if any of the rectangle exists inside the list that has got the same name that we passed in, we say is landing dot rec is equals to rectangle. Okay, so the landing rectangle that we created is going to be linked to the rectangle that we found with the same name here. Okay, so that's all we need to do inside the for each loop, and then once we get out of it, then we can say canvas dot set left to player, and let's say canvas dot get left landing rec. So we get again the position of the landing rec, which is identified inside of this for each loop. Then we'll say plus player dot width times 2. Then let's do a canvas dot set top here. Player again, canvas dot get top of the landing rec, and then we can say plus player dot height divided by 2. So that way, whenever we move the character, it always moves to the middle of the rectangle. So now let's do the restart function. So the restart function is going to be I equals -1, j is equals to -1, move piece player box plus 0, and then do the same for the opponent as well. Okay, let's set the position to 0, current position to 0, opponent position to 0, current position to 0 as well. Player 1 round is equals false, player 2 round is equals to false. Here's a txt player content equals to u rolled a, then space plus position. Position dot content is going to be player is at 1. say txt opponent dot content equals bold A plus opponent position. Opponent is at 1. The content, and we're also going to say game timer dot stop. Okay, so we set up the game, got the move pieces part working, finished the restart game function as well, and now we can start on the on click event. So inside of this event, we'll check if player 1 round is false and player 2 round is false as well. Okay, so if both of those statements are true, then we'll generate a random number. So you can rand dot next between 1 and 7. It always generates a number between 1 and 6. Okay, so say txt player dot content equals you rolled A plus position, and then set the current position to 0. We also need to check if, let's do a bracket here, say I plus position is not equals to 99. Okay, so whatever position that we add, so this is the part where it's calculating the end of the game. So if we are still inside the board and the number that we generated can still move forward, then we'll set the player 1 round to true. Okay, and then game timer can start here. So this if statement is only going to run if the player can actually move forward. So if we are right at the top of the position and the number that we rolled is greater than 99, then what we're going to do is we're going to pass our round to the CPU so the CPU can move forward. Say if player 2 is equals player 2 round is equals to false here, then player 2 round is equals to true. Opponent position equal to round next 1 and 7. Txt opponent dot content equal to rolled A position. Okay, and then we're gonna set the current position of the opponent to 0 as well. Okay, and then say game timer dot start. Okay, so and if this is not true, let's just go else here and say game timer dot stop, and then of course player 1 round is equals to false and player 2 round is equals to false as well. No need for a space there. Okay, so that would be that for the on click event. So the game timer event is what's attached to the game timer. So every time it ticks, this is what we want it to do. So let's start up here and say if player 1 round is equals true and player 2 round is equals false. So it's the player can move, but we don't want the CPU to move just yet. Okay, so and then say if I is less than moves.count. So the amount of children that's available inside the moves list. So as long as the I is still less than that, we want to execute the following. Okay, so if say current position is less than position, which we know it will be because current position gets reset to 0 1 when we click on the board and it generates a random number and saves it inside the position there. Okay, so with each tick we want the current position to move up. Okay, and then we also want the I to move up as well. So it's going current position plus plus and then I plus plus. Okay, and then in this one we say move pieces, move piece, and then right here say player, and then we know it's called box, right? And then plus I. Okay, so as the I is being incremented with each tick, it's going to show the player is moving on the board as well by using the move piece function here. Okay, so else say player 2 round is equals true. Okay, and also what we need to check is I equals to check snakes or ladders, and we also pass in an I here. So this function will determine if we have sort of landed on bottom of a ladder or on top of the snake's mouth. In that case, we can say move piece to player box plus I. Okay, so now let's determine the opponent movement here. Say opponent position is equals to round.next between 1 and 7 txt opponent.content, show what the opponent has rolled. Okay, and then we can set the opponent current position to 0 to set the temp position equals to I in this case. So the temp position is what's going to show us the position of the player. Okay, and also it's going to do the same for the opponent as well. So txt player position content is equals to player is at space plus 1. Okay, so because the board is generating a name between 0 and 99, so that's why we need to add one more to the temp position, because the board images have a number between 1 and 100. So behind the scenes we still one short, so that's why we adding 1 to it, so that way when on the board you when it lands on a 20, it's 19 on the code. So here we have the else statement, if statement. So while still inside the player 1 round, what we'll say is if I is equals 99. So if you have reached the top, then we can stop the game timer here. So this is where we have won the game. Okay, so you can say message box dot show environment dot new line, makes a new line for that on the message box, and say click OK to play again. And then we'll just do a comma here for the title of this. So I just say Moo says. Okay, so that way when the message box shows up, there's a little caption on the top. So you're just going to say game over, you win, and then click OK to play again. And once you click OK, it's going to run the restart game function. So when the restart game runs, it's going to reset the player and the opponent's position. Okay, so that's that one. So this is the one that we're running for the player here. So I can, okay, that's the if statement for the player. Let's do an if statement where player 2 round is equals true. So say player 2 round is true. So if this boolean is true, then we need to check if j is less than moves.count, if opponent current position is less than opponent position. What we also need to check is and the bracket here, say j plus opponent position is less than 101. So in this if statement, we're checking if the opponent position current position is less than the opponent position, which we know is going to be true because opponent current position gets reset to 0. But what we also need to check is if there are spaces in front of the opponent to actually move. Okay. So the reason I put that one to 101 is because when I set it to 100 or to 99, the opponent didn't move accordingly. So when it got to right at the edge of the board, if you needed to roll a 2 or a 3, it didn't do it. So it didn't quite move to the position. So I had to put 1 up. After putting 1 up, it started to move accordingly. Okay, so inside of this one, we're going to say opponent current position plus plus. We say j plus plus. So move piece, this time we're going to move the opponent. Say opponent box plus j. Let's tidy it up a little bit. else here, say player 1 round is set to false now. So if we have done the move for the opponent, so player 1 is, and then player 2 round is equals to false as well, and then obviously j is equals to check snakes and ladders j, because that's going to return an integer, so we can actually assign it to the integer that we have here. Okay, and then of course if we do get, you know, bottom of the ladder or the top of the snake, then we can move the opponent and then move it to plus j here. Okay, temp pause again to j, similar thing. So txt opponent position dot content is going to be equals to opponent is at plus temp pause plus 1. Okay, and then we stop the game timer here. Okay, so let's get out of this if statement while still inside the player 2 runs is equals to true. So we'll say here is j is equals 99. So the opponent has made it to the top of the scene. Game timer dot stop, and then just copy and paste that message box here. We can copy and paste all of them. Stop, game over. So you can just say here opponent wins. Click OK to play again, and then move says is fine. Okay, so this is going to be the entirety of the timer event. Okay, so except for the check snakes and ladders function, we have got pretty much all the functions done now. So let's run this game and see how it actually works. Okay, so the player and the opponent have been positioned there. So if I click on the board, so the player rolled a 2, opponent rolled a 1, so opponent is still a number 1. Click again. As you can see, the player is moving forward, opponent's moving forward as well. It's also updating which position the player is on, which position the opponent is on, which position the player is on. Okay, so let's see. So right now we won't be eaten by any of the snakes or jumping up on any of the ladders either, because that function doesn't do anything yet. Just want to make sure we can reach to the top there. Just want to make sure when the player or the CPU gets to the edge, they stop and until they get a certain number. So right now the CPU rolled a 4, but it can't move anywhere because it's on 98, so it needs to get something smaller. So it also rolled a 6, so it needs to get something smaller than that. So it rolled a 1. Okay, that's fine. I rolled a 5, but I have 4 spaces. Rolled the CPU rolled a 5, I rolled a 6. Okay, so by the looks of things, they stop on the top there. That's perfectly fine. So this is basically a screenshot of the game. So if you notice here, right, so when we move to number 1, the ladder, that's the ladder's bottom there, and then we can move up to the top of the ladder, which is number 38, and then we have another ladder and number 7 that moves up to 14, and then the number 8 moves up to 31. Okay, so what I've done is I've went through tile by tile just to check which one you can land on and then move up. And if you land on a snake's mat, so for example the first snake we encounter is on number 16, if you encounter this one we move down to number 6, and then obviously we move back again. So it's the same way to basically double check. Now one of the things to remember is that although these ones are showing at 1, 2, 3, our numbers that we generate is 1 less than the one on the board. So this one is showing number 2, but in reality the game is going to check with number 1. Okay, let's take a look at how we can do a few, and then I'll also put the source code in the link in the description, so you can take it from there as well. Okay, so the first one we're going to check is, say for example, if we make it to, if num is equals to 1, so when the round has finished and we landed on 1, then we can go to num 37. Okay, the same again. So let's say if num is equals 6, then num is going to be equal to 13. Okay, so that's another ladder. And then let's say if num is equals 7, That's the number 8. So that's the longer ladder. That's going to land us on number 30. Okay, and then another one is if num is equals 14. Okay, then num is equals to 25. Okay, and if num is equals 15, that's going to drop us down to num is equals to, the number is going to be equals to number 5. Okay, so if you look at this group of if statements here, what it's doing is it's basically just checking the number that's passed through in this function, and then we're going to change the integer and then we're going to return it back to the function. Okay, so the way it works is as soon as the round has finished, so as soon as the player or the opponent has made their move, right after that, so once the current position is greater than the position that was generated, it basically saves the j, which moves the player using the move pieces function there, and then checks it with this checks next in ladder, and when the j is then passed down into the function, it's going to check with all of these numbers to see if j is equals any of these numbers, and if it is, then it'll just change the j's position to that. So if j is equals to 7, it's going to change it to 30, or if j is equals to 15, it's going to change it to 5. Okay, so I had to go through basically all of the tiles just to make sure that we know all the positions for them. Just remember that it's one less. Okay, so right now the snake's head is on 16 on the board, but in the code it's 15. So if it hits 15, then we need to move it back down to 5. Okay, so it's going to go down here. Right, so I'm just going to fill in the rest of the function. Okay, so rest of the function has been filled in now. I'll scroll down this function so you can take a look at all the numbers. Okay, so now we can actually try the game out. Okay, so let's see if we can get to the bottom of the ladder. That happens first. So as soon as we rolled a 2 from 1 2, it went up the ladder. So let's see if we can move. Okay, so then we hit this one here. So we were on top of this snake, and then it moved down. The opponent went from this tile here all the way up to 83. Okay, so now the opponent got eaten from 95, came down to 75. Okay, I hit this ladder here, went up to 44. I got eaten by another snake, so went from 46 to 25. And then jackpot 28 to 84. Okay, very close. Okay, so now we are both kind of right in the edge. Now the opponent rolls a 2 and wins the game. So now I can click OK to play again. So then the position and everything else gets reset back. So this has been a tutorial on how to make a snakes and ladders game inside of Visual Studio using WPF and C# programming. I hope you guys enjoyed this tutorial, and I will see you on the next one.